Hello, everyone. My name is Pedro Rendon. I work for the International Atomic Energy Agency, USDA APHIS Science and Technology Moscamed Program in Guatemala City. Thank you for inviting me to this 2023 China International Conference on Nuclear Technology Application. The subject that I'm going to be discussing with you today is Moscamed Program operating the effective control of the Mediterranean fruit fly in coffee production areas. So the content of this presentation is historical background, achievements in detection and control activities, the current status, cost benefit, and future strategies for the program. The historical background is that the Mediterranean fruit fly Ceratitis capitata weed from the Tephritidae family, also known as Medfly or Moscamed in Spanish, is considered one of the most important pests worldwide due to the direct and indirect damage to the fruit and vegetable production. This indirect damage is introduced in terms of quarantines that are lifted to those countries that have detections of the pest because of the interest of not sending contaminated material to the importing countries. So quarantines will damage the producers, will damage importers, and it's a serious problem together with the direct damage that the pest may have to the fruit. We can see a caption here where part of the control is to do burying of fruit as part of the mechanical control of the pest in order to reduce the possibilities of having next generation growth in those production areas. So the Mediterranean fruit fly is present worldwide, and this is due to the high capability of the fly to adapt to different climates and different fruit. In fact, one of the aspects that is occurring with the Medfly is that it has a long list, around 400 fruit and vegetables, which can use as hosts in the different continents. For the particular case of the American continent, we have some of the countries that you can see in green in this map are countries that have been able, due to the correct use of technologies and the timing of the operations, have been able to eradicate the pest, and they are enjoying the opportunity to have or participate in an international market for selling fruit and vegetables to the rest of the countries. That's the case for Chile, the case for Mexico, the US, in some regions in Argentina. So one interesting aspect to notice also is that coffee production areas are related to the presence of Moscamed. Certainly in the American continent, again, the presence of coffee from Brazil up to the south part of Mexico is an important fact that allows Mediterranean fruit fly to survive and have a continuous host in the whole of this area. The Mediterranean fruit fly, then, in summary, is originating from Africa, is a cosmopolitan pest that has more than 400 fruit hosts. In the American continent, has the presence of a major host, which is coffee, but is also having the opportunity to have hosts in different fruits and vegetables. And then in our regions, normally, it will have the advantage of having a difficult topography from which they take advantage to produce hotspots in high persistence areas where they can reproduce at a high growth rate and then disperse to new areas, closing the cycle of permanence of the Mediterranean fruit fly in this continent. So the Mediterranean fruit fly has more than 120 years of presence in the American continent. And one wonders how that happened. And the story behind this is the following. Mediterranean fruit fly was introduced to the American continent in 1901 in Brazil, and then it moved to different countries, as you can see in this map, reaching Costa Rica in 1955, Nicaragua in 1960, and Guatemala in 1975. By the time the Mediterranean fruit fly reached Guatemala in 1975, there were countries that, I started to saying the formation of the Moscamed Program, the governments of Guatemala, Mexico, and the USA, in response to the Medfly reaching Guatemala and Mexico in 1975 and 1977, joined efforts to form the Moscamed Program, aiming to contain the northward spread of the Medfly to avoid its establishment in free production areas of Belize, Mexico, continental US, and Guatemala, eradicated from areas it had invaded in southern Mexico, and in the longer term, eradicate from Guatemala. Activities or control activities that the program conducts, as stated before, coffee is a major host for the area. And as you can see in this caption, coffee berries actually produce a good opportunity for larvae of the medfly to survive. Sometimes 2 or 3 larvae are found within each of these coffee berries. Now, coffee bushes produce around 25,000 coffee berries per year. And so you can imagine that if the presence of coffee goes from the south of Mexico down to Brazil, and when the prices of coffee are low and the growers do not collect the coffee because of the coffee prices being down, there is a huge opportunity for this pest to reproduce and be able to migrate to new areas, causing problems to other crops. In this particular case, we have in Guatemala the event of 28 or a little bit more than 28 additional hosts having been detected as medfly hosts. So when the coffee is not available, the medfly still has the possibility of moving to additional areas in order to remain in the country or remain in the production areas. So that's an important fact that complicates control activities. So in order to know what is the presence of the Mediterranean fruit fly in the areas, we use what is called the pest monitoring and the trapping systems. And the trapping systems basically take advantage of artificial development of attractants such as trimethylure placed in traps, and we have a census of the presence of the flies in the respective areas. We also use female attractants such as the 3-component lures to attract the females and determine, again, the presence of the pest in production areas. And with this piece of information, we are able to produce graphs by month that determine when the populations are higher and how this presence can be reduced in order to avoid distribution of the pest to new areas and maintain, again, free and low prevalence areas. So the graph that you're observing here is the result of the review of about 10,000 traps. Most of them are reviewed weekly, and so we are able to produce a graph that determines when the majority of the pest is present in the field. Based on this information, we also conduct, with the use of geographical information systems, we conduct this mapping that allows to spot where areas have the highest population using an index that is called the FTD, fly per trap per day. And this FTD allows, based on the traffic light system, where the red means more than one fly detected and so on, we are able to determine what we call hotspots of the presence of the pest, most likely from where the pest is going to disperse to new areas, and be able to um, derive a strategy for the control of the pest using this traffic light system. So obviously, the red color is the one that we are going to pay most attention in terms of chemical control, and then the other colors will allow us to know the intensity of the presence of the pest. And when we get to the color green is when we can use sterile insects to be able to move from the green color of 0.05 or less to 0 and declare eradication of the pest. So basically, the format in which this is being done is using an area-wide concept where commercial production areas are spotted, and if they happen to have or be part of the hotspot areas, then everything around them is treated so that there are no opportunities for this pest to survive in back patios, in protected areas, in homes, in abandoned groves. And this area-wide concept is a very important concept because it's a more benign um, way of controlling pests for the environment. And it also allows a uniform treatment of the pest, not a farm by farm response in which growers will most likely use the product of their preference or the product that they would like to use based on the cost, but a standardized system of responding so that all the producers are organized in a way of being more effective, cost effective to control the pest. So with that, the initial treatment is done by the use of aerial or ground-based sprays, where the idea is to reduce the populations based on the use of an organic product. This organic product is sprayed in a cycle of 7 days and coming back at the 7th day again to re-spray those areas, and with the idea of being able to reduce the population growth, and after that, bringing sterile insects. So in the meantime, the rearing facilities, such as this one that you're seeing at El Pino, is in the process of producing large quantities of sterile insects and then sending them to emergence and release facilities where those flies are going to be received, placed on special containers to allow them for emergence and sexual maturity, then chilled down and placed in planes. The planes, using a geographical system, also will identify specifically the areas where they are going to be released. These insects are going to be released from the plane, and they are going to mate with the wild counterparts and be able to reduce the population. So in summary, what we are seeing is the following. Based on the population curve that you saw in the previous slides, we determined that the population needs to be reduced right at the end of the previous year, in this case, October and November and December. So bait sprays and ground sprays are applied there in this initial or final and initial months for the coming year. And then the population is reduced, like you are seeing in the dotted line in red. And once that is done, then the release of sterile insects is conducted. I must say that um, at this stage, we are applying only 5 days out of 365 days of the year we are applying chemicals or we are applying this organic pesticide 5 days out of 365, and the rest of the weeks of the year, we are using sterile insects for the control. So in that way, there is a combination of the two technologies, but the majority of the work is being done by sterile insects. So the results of that activity are shown in this map, where you can see the white blocks in here, in these areas, and white blocks in this area here. We use the traffic light system to spot the areas that have presence of the pest, as explained earlier. And we have greens and oranges here. In this north part, we have basically no presence of the pest in these blocks in the south. And this again is the result of the combined effect of aerial sprays, ground sprays, and the release of sterols. So altogether, with all of this information in all of these activities, what we are seeing is basically that the program has effectively served as a containment barrier, maintaining the Mediterranean fruit fly free status of Belize, Mexico, and the US, while protecting and increasing the free areas in Guatemala. And as a result, it has protected the assets of horticultural producers and contributed to the development of export industries. In the case of Guatemala, from areas up in the north, for instance, in this case, the Petén, these areas are producing papayas for the export markets, and these are the results of combined exports of mango, chili, tomatoes, and papayas, and the growth that we have seen from 2005 down to 2019, considerable growth in exports and in income to those communities that are surrounding those areas where the program is having activities. So in terms of the cost benefit and future strategies, the return on investments as measured in microeconomical terms through the cost benefit analysis gives a favorable 150 to 1 cost benefit ratio, according to Enkerling and AICA in 2009. The cost benefit figure shows that the governments of the participating countries have made right decisions in terms of continuing the best of resources in programs such as the Moscamed Programme, without considering the social aspects and environmental benefits that the program entails for the countries involved. So the future strategy is to continue preventing the northward spread of the pest and collaborating with producers to clean areas and promote the production and commercialization of healthy produce. Thank you.